Okay, so this is still section 11.2. We're on problem 26. A standard 52 card deck is shown below. Suppose one card is randomly selected from the deck. Okay, so here's all 52 cards. Again, you really have to know just the basics about a deck. There's 4 suits. The hearts and the diamonds are the red suits. The spades and the clubs are the black suits. There's 4 in each suit. Okay, the hearts and the diamonds are red. I think I already said that. The spades and the clubs are black. Okay, and sometimes work with face cards. Jacks, queens, and kings are face cards, and ace is not a face card. Okay, so that's really all you have to know. Okay, any games would have to be explained. The rules. So part A, compute the probability that the card is a 2 or a 3. Okay, so by the way, I do have mutually exclusive events because I can't select a card that is a 2 and a 3 at the same time. So I just got to find the probability of getting a 2 plus the probability of getting a 3. There's 4 2s in a deck, 4 3s in a deck out of the 52 cards total in a deck. So that's going to be 8 over 52, which reduces down to 2 over 13. Okay, and of course reduce as far as you can go with this. Part B, compute the probability that the card is a 2 or a 3 or a 4. Okay, so here I've got 3 events. That shouldn't matter. I'm still looking for the keyword, which is or. I've already said that this is mutually exclusive, okay, since a card can't be a 2 and a 3 and a 4 at the exact same time. So all I have to do is add these probabilities together. The probability of getting a 4 is 4 out of 52. So if I add 4 over 52 plus 4 over 52, I get 12 over 52. Or 3 over 13 is what that reduces to. Part C, compute the probability that the card is a 2 or a club. Okay, so 2 or a club. Or is a key word, so I'm going to be adding, right? Now, I don't have mutually exclusive events going on. In other words, I can select a card that is a 2 and a club. Okay, so I got to make sure that I subtract that probability. The probability of getting a 2 is 4 over 52. The probability of getting a club, there's 13 clubs in a deck, so 13 over 52, minus the probability of the card being a 2 and a club, or the 2 of clubs. There's only one card that is the 2 of clubs out of the 52 cards total. So that's going to give you 16 over 52, or 4 over 13 when you reduce. Okay. Part D, compute the probability that the card is not an ace. So if it's not an ace, then we want it to be an ace, but the complement of that. Okay, we use the complement rule. Take 1 minus the probability of getting an ace. Or there's 4 aces in a deck, right? So 1 minus 4 over 52, because it's 48 over 52, or 12 over 13. Okay. And, so something like this, I don't feel like, you need this much writing, okay? If you need the card to not be an ace, and there's 4 aces in the deck, well, 48 are not going to be aces, right? So 48 over 52, reduce that, and you're done. Compute the probability that the card is not a face card. Okay, so probability that is not a face card is equal to 1 minus the probability that the card is a face card. There's 12 cards that are face cards, okay? And if I highlight them here, they'd be these 12 right here. So kings, queens, and jacks. There's 4 suits, so 12 over 52. 1 minus 12 over 52 gives me 40 over 52. Reduce that, so you get 10 over 13 is the answer. Part F, compute the probability that the card is a spade or a red card. Okay, a spade or a red card. well, a card can't be a spade and a red card, right? So I have mutually exclusive events. 13 cards in the deck are spades. 26 of them are red, 26 are black. So 39 over 52, or 3/4, would be the probability that the card is a spade or a red card. Part G, find the probability that the card is a spade or a face card. Okay, so the probability that it's a spade or a face card, or is the key word, so I need to think addition rule. I got the probability of getting a spade plus the probability of getting a face card, and I don't have mutually exclusive events in this one, so I need to make sure that I subtract the probability of getting a spade and a face card. Okay, 13 out of the 52 cards are spades. 12 of them are face cards. Okay, now how many cards are spades and face cards? Well, you'd be looking at the king of spades, the queen of spades, and the jack of spades. Okay, so these 3 out of 52, if I subtract those, because I don't want to overcount, it gives me 22 over 52, which reduces down to 11 over 26 is the answer. Problem 27, 2 6-sided dice are rolled. Okay, part A, what is the probability that the sum of the 2 numbers of the dice is an 11 or a 12? Okay, so or is the key word. I have mutually exclusive events, since you can't roll a dice and, get an 11 and at the same time get a 12. Okay, that's impossible. So I just need to add these 2 probabilities here. The probability of getting an 11 would be 2 over 36, excuse me. Let's see, to get an 11, you can get a 5 and a 6 or a 6 and a 5 are the 2 ways. There's only one way to roll a 12, right? That's if both the dice show a 6, right? So 2 over 36 plus 1 over 36 gives me 3 over 36, or 1 over 12 when I reduce. Part B, what is the probability that the sum of the 2 numbers on the dice is an odd number or greater than 9? Okay, odd or greater than 9. So let's see, if you're greater than 9, that means you're 10, 11, or 12. I can't roll higher than a 12. So I'll need to make sure that I use the regular addition rule here. I need to take the probability of getting an odd number plus the probability of getting a number greater than 9, and then subtract the probability of getting an odd number and that number is greater than 9. Okay, so let's see here. The probability of getting an odd number would be probability of getting a 3, a 5, a 7, a 9, or an 11, plus the probability that it's greater than 10, or greater than 9, excuse me, is a 10, 11, and 12. If you want the number to be odd and greater than 9, there's only one of those numbers, 11. So let's see here. The probability of getting a 3 would be 2 over 36. To get a 3, you get a 1 and a 2, or a 2 and a 1. Probably getting a 5 is 4 over 36. So that'd be a 1 and a 4, a 2 and a 3 and a 2, or a 4 and a 1. Probably getting a 7 is 6 over 36. So that'd be a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. Probably getting a 9 is 4 over 36. So that'd be, let's see, you get a 3 and a 6, a 4 and a 5 and a 4, or a 6 and a 3. And then to get an 11, there's 2 ways to get an 11. We said you get a 5 and a 6, or a 6 and a 5. Okay. How about probably getting a 10? Well, there's 3 ways that you can get a 10, right? So that'd be if you get a 4 and a 6, a pair of 5s, or a 6 and a 4 gives you 10. Probably getting 11 is 2 over 36, we said. So that's if you get a 5 and a 6 or a 6 and a 5. And the probability of getting a 12 is 1 over 36. There's only one way to get a 12. That's if both the dice show a 6. Minus the probability of getting 11 would be 2 over 36. So again, a 5 and a 6 or a 6 and a 5 gives you an 11. So the first probability fraction, 2 plus 4 plus 6 plus 4 plus 2 is 18 over 36, plus 6 over 36 minus 2 over 36. That's going to be 22 over 36, or 11 over 18 when you reduce. Okay? Problem 28. Suppose that we want to form a 3-digit number using the set of digits 0, 1, 2, 3, 4, or 5. For example, the number could be 501 or 223. But 035 is not an example. Okay, so in other words, the first number can't begin with 0. Okay, you can repeat digits. That's okay. So part A, how many such numbers are possible? Well, if the first digit can't be a 0, then any one of these other 5 are going to be okay. The second digit can be anything, and the third digit can be anything. Okay. Any one of these 6 numbers. So 5 times 6 is 30, times 6 is 180 possible numbers. Okay. Part B, how many of these numbers are multiples of 5? So to be a multiple of 5, the number has to end in a 5, or it could end in a 0. Okay. So there's 2 possibilities there for the last number, okay, whether it be a 5 or a 0. In the first number, remember, you can have 1, 2, 3, 4, or 5, or 1, 2, 3, 4, or 5. You can't have a 0 there. And then the second digit can be anything. Okay, so 5 times 6 is 30, times 2 is 60. So 60 numbers are multiples of 5. If one 3-digit number is chosen at random from those that can be made from the above set of digits, find the probability that the one chosen is not a multiple of 5. Okay, so 60 numbers are multiples of 5. There's 180 numbers total. So 120 numbers are not going to be multiples of 5. So 120 over 180, or 2/3, when you reduce that, that'd be the answer. Okay, problem 29 is the last one in this section here. So it says that an experiment consists of spinning both the spinners, shown to the right, and multiplying the results together. Okay, assume that it's equally probable that each pointer will land on any one of the numbered spaces. If the pointer lands on the borderline, just disregard the spin and spin it again. That way you have a definitive number to work with. Part A, list the sample space. Right here is the answer is a set. Remember, the sample space is always a set. So let's see, if I spin a 1 and I spin an 8, a 9, or a 10, then 1 times 8 is 8, 1 times 9 is 9, 1 times 10 is 10. If I spin a 2 and an 8, a 9, or a 10, 2 times 8 is 16, 2 times 9 is 18, 2 times 10 is 20. Okay. What if I spin a 3 and then an 8, a 9, or a 10? 3 times 8 is 24. 3 times 9 is 27. 3 times 10 is 30. And what if I spin a 4 and then spin an 8, a 9, or a 10? Well, 4 times 8 is 32. 4 times 9 is 36. 4 times 10 is 40. Okay, and that'd be all the possible numbers there to list. So I'd close up the set. Part B, find the probability that the resulting product will be an even number and greater than 20. Okay, so we're greater than 20. Means that we're not including 20. An even number, so there should be 12 numbers total here in the sample space, so 12 would be in the denominator. Let's see, 24 is even, 30 is even, 32 is even, 36 is even, 40 is even. So only 27 is not, is odd. So it looks like 5 out of the 12 should be the answer there. Okay, so 5 twelfths. All right, so that's it with section 11.2. The homework is in the book on page 623. So be sure to look at the problems there for me when you get a chance. And when we get back, we'll begin section 11.3, which is all about the multiplication rule and the conditional probability rule.